In this video, we are going to learn how to do an extensive exploratory data analysis for a given dataset. The data which we are getting might be structured or unstructured. We don't know. But these types of data analysis helps us to know the nature of the dataset. These things also helps us to do the model selection or like the thing what we have decided to do with this dataset is suitable for this dataset or not. So let's start. Here we are going to take the New York dataset, which is one of the famous dataset for our data exploratory analysis. So let's fetch the dataset here. Yeah. Here by clicking this, we can get a dataset. Yes, I have got the dataset with the extension of CSV. Fine. Let's take the dataset and yeah, put it in this folder. Okay, so I have already opened the Jupyter Labs. Here, let's create a new Python notebook and name it as, let's say, exploratory underscore data underscore analysis. So yeah, let's start these things by importing the required packages. Yeah, before importing, if you see here, just now I have pasted that downloaded dataset here, like NYC jobs. This is the name of the dataset, and this is in the format of CSV, means comma separated values format. And here you see this is the complete data, and also check whether you have any irrelevant data inside these things or not. These missing values, these things will be taken care of, but let's have an overview of this data set. We need to check whether we have anything like Unicode values or something like that, which is not relevant to our actual data. So if you see, almost we have around 4,000 plus rows, and yeah, I don't know, about 12 to 13 columns. I'm not sure. We can check here. Fine. Let's start by importing the packages. Here I'm importing NumPy, pandas, and mainly we will do all six analysis from the packages matplotlib and seaborn. Matplotlib is something which helps us to derive various forms of graphs, whereas seaborn helps us to derive various forms of visual things from the available dataset. So both of these datasets are very important if we want to do any kind of data analysis. Here we are going to use matplotlib package, and from it I'm deriving pyplot. Then I'm importing CMON. Let's run this. Fine, perfect. So let's import the dataset here. I'm naming the dataset here as TF, means data frame. I'm using read CSV method from pandas. So here I'm going to define the package. We are having the data inside this dataset folder. So dataset NYC jobs, everything in uppercase dot CSV. Let's run this. Yeah, fine. So if we want to check the structure of the data, we can use the head of method here. So if I give head of alone here, df.head of, it will show you, it will give you the first 5 rows of the available data set. So which means 5 rows. That is here the index is given. It is starting from 0 till the 4th row, and it has 26 columns, right? 26 columns, and we also can have the column heading as well here. So if we want to customize these things, the default is 5 rows. If you want to customize, we can customize it. Here we have given the number as 3, which means it will return the first 3 rows of the data set. So yeah, fine. So here, which means the data from the CSV file is stored in the data frame TF variable. Next, we are going to check the shape of the data set. For this, we are going to simply use the shape method. So it will give you the rows into columns, which means the first component describes the number of rows inside the data set, and this is the column. Here in this data set, we have 4190 rows and 26 columns. So yeah. Next, let's have an overview of the data. Yes. So with the help of describe method, we can have the basic algebraic values of the numeric data. We actually have two types of data, categorical and numerical data. So here, if we give the describe of method, the system, the compiler itself takes the columns which have the complete numerical value and gives these basic information like count, like how many unique values are there, the count, the mean value, the standard deviation, then the minimum value, the maximum value, then what will be the 25% of the value, everything. These and what will be the maximum value. All these things we can get at a stretch by using this describe of method. Then we also can have the overview of data by using this info of method. With this info of method, we can get the overall type, the data type. Here, what we are having is data frame type. The range value, the range is 4190, which denotes the rows, and the columns is 26 columns. Here, we are also getting the column name and the number of values and whether it is what kind of values it has, null values or non-null values, then the data type, whether it is an object or integer. Mostly object in the sense it denotes a categorical value, and if it is of integer or float, it is numerical value. Going forward, we can use either these values or these column names to fetch the each and every column. So in this particular data set, if you see, we can have the salary ranges like salary range from and salary range to. Let me show you salary range from and salary range to. So what we wanted to have two different things to calculate a salary. So what we are going to do is we are going to derive another column called average salary, which actually carries the mean of these two columns. That is the one thing that we are going to derive now. Then we are also going to normalize the value, because for analysis purpose itself we need to normalize these values. Here if you see, few values are given annually, like the salary, few salaries are given annually, few salaries are given in hourly basis, and few things are given in monthly basis. Yeah, few things are given in monthly basis. I'm not sure where it is, but yeah, these things are here, like the annual, the hourly, and monthly basis. So everything we are going to convert everything into something like hour basis. Let's see how to do it. So first we are going to have this thing average salary as our new column, and what we are going to do is we are going to fetch, basically this thing means we need to take all the rows, then we are going to take salary range from and salary range to. Then we are going to find mean value along its column. This axis equal to 1 denotes we are going to calculate the value along the column. So finally we are going to assign all these steps to the new data frame. That's what this means. Fine, perfect. So yeah, now we are going to normalize everything. So average salary equal to so we are going to do this thing with the help of the salary frequency. So yeah, if the salary frequency is daily, then we are going to multiply it with 5, which means 5 working days per week. Then multiplying it with 52, which means 52 weeks per annum. And we are going to again assign these value to the same average salary column itself. Yeah, let's run this. We're having some error. Right? The same thing we can copy and paste here. We have done only for daily. Again, we need to do it for hourly. Hourly means we need to include, 35 hours per working hours per week. So we are including 35 here instead of 5, and we are running this thing again. So yeah, fine, perfect. We got that as well. So let's find the mean salary. I'm going to take the integer value of everything. So if you want to see the value, what is there inside a particular variable, you can simply run that value. Like if I simply run mean sal, it will give the value, which means 72k is the mean salary, whatever the case you take for the entire column. So now what we are going to do is we are going to add another column called income. Then if the particular row, particular job ID has the salary less than the mean salary, we are going to assign it with 0. If it is greater than the mean salary, we are going to assign it with 1. Let's see how. Like we are using the where condition. Then tier 4, we are going to take the average salary column. So there we have already calculated our mean salary. So yeah, if it is lower then 1, if it is greater than 1, if it is lower then 0. Then we are going to assign it to name something like income. Yeah, done. So we have calculated our average salary and also we have calculated our mean salary, and we are derived with our another column called income, which actually carries whether the particular job ID has salary which falls with lower average category or the upper average category. So fine. Now let's see how to get the correlation thing of it. So just C O or R method gives the correlation matrix of the value, like how we got for the describe of method. In the same way, this thing will give our overall picture of the correlation things between the numerical columns of our data set. So later we will see how to get the correlation matrix for everything. Just here with this straightforward CORR method, we can get the correlation matrix of the numerical columns. So here, as you know, so as the value nears to the value 1, those two things, those two columns have similar values and we can omit either of the one, and this can be manipulated in many other ways. So yeah, fine. So hereafter we saw how to derive the value, how to see overall picture of the data, and how to get the correlation matrix. And hereafter, we are going to compare each and everything. Here, the actual analysis starts. We are going to compare each and every column with our average salary and what influence it actually has with our average salary column. So let's see. So for this particular thing, maximum will be using the Seaborn method, Seaborn package. We are going to plot in many graphs using the many types of graphs available in Seaborn. So here I'm going to take the income column what we had, like the X column denotes the income and the data frame, the data is the DF. And we are going to put a count plot. Yeah. Here we got a count plot, which means the total value is around 4000k plus, where the people who are earning less than the average salary or about some value around 19,000, and the people who are earning above the average, above the mean value, are around something like 2000. More or less both are same. We are not having any much difference between the distribution. So with this thing, we can conclude like the data is more or less balanced, and this particular data set will give us the unbiased result. So hereafter we are going to do the analysis, do the detailed analysis with each and every column. So let's take the column agency. We are going to plot at this plot with this column. Like let's take the number of positions. Yeah. So here is the graph. So if you see the distribution of data over the number of positions, the data which has the position like the vacancy like 1 position or the number 2 position or some like the single digit, we can see it has a more data like around some 8 to 10% of data, and the remaining thing like the job IDs which has something like 50 number position or 20 or 30 position or very low, too low, which means the job IDs are coming. There are no massive things are coming up. Massive, they are not recruiting for massive things. They are just going to these things, the New York jobs in the year 2020 or 2021 as per the data set. They are filling only for one job or two job, etc. So let's take the salary range from and salary range to columns and then try to do the same plot for those two columns. Yeah, here is the data. So if you see more or less it follows normal distribution, which is a good thing, good sign. So usually if the things follow normal distribution, then the data is good. We can use the linear regression, logistic regression, decision tree to predict the values here. And if you see the salary range too, it also follows the same thing like the normal distribution. And if you see both these graphs, they look similar. The distribution looks similar. We can also take our derived column like the average salary. We have derived a column, right? So we can also check the distribution of the value. Yeah, it follows the Paga normal distribution value. We are going to see about the civil service title column here, and we are going to compare the column with the average salary. Let's do it. The first thing is I have grouped it and giving the column name civil service title and here average salary. I have combined both the things like the average salary range from and salary range to, and I have derived the column called average salary. So hereafter going through the code, I'll be using average salary as a comparison matrix for all the columns. Yes. Civil service title spelling mistake. Okay. Not fine. If you see, there are many civil service title, and here the name, the civil service title with accountant has the average salary value around this 48789, and the number of the same replica values, the number of job IDs with the same title and the same average salary are around 6. So likewise, we can find the many things here. There are many rows, and these things are they have hide marked, and they have only few things. So if you see, there are 1092 unique civil service title values here. So if you want to sort everything, you can use this snell method, and then after summing it, you can sort the values. I'm doing it in ascend. I'm doing it in descending value. Yes. Like whatever the data is here, these things will be in the descending order. Here with this string we can see how many how many null values that each and every column has, and the count will be displayed here. I have displayed it in descending order. So the column which has a name like recruitment contact, this particular column almost has all the values as null values, and this post until has about some 70% of the values as null values. The column this minimum qualification requirements has 12 values as its null values, and to apply this column has about only one value as a minimum as a null value. So here what we can do is we can completely ignore this column, and when we come to apply column, we can simply ignore the row which has this null value. Since it has only one, it is completely negligible, and we can ignore this particular row and we can proceed with that problem. So let's see what we can do with this post until and minimum qualification requirements, and what are the other things we can follow. Let's see those things. Now we are going to analyze the job ID. So if you see, we have almost something like 3 2 1 replicator job IDs here. So, and the unique number of job IDs are around 2152 jobs, which is a pretty length, and we don't need to do any kind of further analysis with the job ID. It's simply a unique number, and it is simply an ID. That's all. We can leave it. And let's have a look on agency column. Yeah, here if you see, we have around some good number of agencies. I'm not able to count here, but still, yeah, if you see, we have only some around 20 to 30 agencies here, and let's see whether we can compare anything or not with the help of these agencies. No, we are not going to do it because we have around some 20 or 30 agencies, and I think these agencies will not contribute anything to the salary. So let's dive into the next column, which is posting type. If you see a data set as a whole, we can have many types of data. That too from the real time. If we are doing a web scraping, or if we are gathering the data from a form, we can have a variety of data. And why I'm doing, we almost have 26 columns here. Why I'm doing all these steps are like I need you people to know what are the different types of data available, and how can we or how can we get the insights of the data, whatever the data might be. The data itself is useful, and we should see what data we can derive out of it, what information we can derive out of it. So yeah, so posting type we have only two things like internal and external. So internal, if you see, we have around some 2000 plus, and external, if you see, we have around some 1900 plus, almost the same, and both things are balanced. So if we put a box plot for this, since it has only two data, it will be easy for to put a box plot. So if you put a box plot for this, while comparing it with the average salary, so let's put answer. Number of positions. I'm sorry, this is posting type, right? Yes. If you see, the range is almost same. Like whatever might be the job, the internal thing or external thing, the range is same. So let's move to the next thing, like the number of positions. Let's have an overall look first, then we'll put a graph. Yes. Actually, the data is completely decreasing, and if you see for the job IDs with only one single position, we have around some 3K. But if you see, the things are decreasing as the number increases here. And let's put a graph and see. Let's put a box plot for this. Here, if you see the job IDs which has the least number of vacancies, like the 1, 2, they tend to provide more salary than the job IDs which have the more, like the 100, 150. Then they tend to provide very lower salary. If you see from this box plot, we can get that. Fine. So which means this number of positions also have a little significance on the average salary column. So which means we can use this thing as an important one of the important feature when we derive something like, or when we create a model, or when we develop a model, we can use this number of positions as a column. So let's move to next column, which means the business title. First, see the value counts, like how much and what are there, the overall thing. Yes, we have around some 1600 plus business titles, and these things are almost unique. So we don't need to worry about this thing. If you put, if we plot graphs also, this does not make that much sense. We can move to the next thing. We can move to civil service title. I think civil service title, yeah, we have done it. We are done with the civil service title. So next we can go to title code number. Dot value counts. Yeah. So the same here, title code number, these things, the unique number of unique title codes are like 333, and if you again put some box plot or some kind of these kind of box plots, this will not give any clear idea. So we are moving to next thing. So next column is level. We are going to see what the column level gives us. Yeah. So fine. If you see what I guess here from is like the more jobs are open for freshers, whereas only limited jobs are available for the experienced people. So first, what we do is we'll sort the levels and we'll try to plot the graph here. So let's put a box for M. Sorted the level, like we have levels here around some 0, 0, 2, something M3, M4, 1B we have. So we have sorted everything, and let's plot with the sorted value. Let's put a box plot here. Sort. We are going to compare everything with the average. Yeah, let's see. Here, if you see, the freshers tends to get lower salary than the experienced. So I think M6, M7 are the highest positions, and if you see the people who are there for that particular position, they have more salary slab, and the people who are there in the levels 0, 1, 2, 3, 4, 1B, they tend to, so which means this level has a direct significance over the average salary, and I think this might be one of the important feature when we develop a model. Let's move on to salary frequency. Yes, so we have three things like annually, hourly, and daily. And if you see, most of the people are getting paid on annually basis. So let's check whether do we have any relation with this thing and average salary or not. So for that particular purpose, we are going to do a box plot. So yes, if you see the people who are being paid annually tend to pay more, and the people who are being paid daily basis also tend to pay more, but the people who are being paid on hourly basis tend to pay less. So this may influence the average salary column. So this also might be an important feature to calculate or to predict the annual salary. And we also do have division or work unit. Let's see what is the status of the column and what kind of values we have in it. Yes. So we do have around 716 unique values here in under division and work unit column. I think we no need to plot any kind of graph for it because it is pretty quite large number of unique values this has, and we can move on to the next thing like the posting date. So yeah, if you see the posting date, it is also has around something like 387 unique values. So fine, we don't need to worry about these things. This will not contribute much to the our average salary. So let's have a look around residency requirement. Yeah, okay. So if you here see the residency requirement, only four things. Though we have these much unique values, hardly we have around some four or five things like the New York City residency is required within 90 days. This is required within 180 days, or the New York City residence itself is not required. So for this particular thing, we can later define it. That's completely some different topic. So here we are going to have one of the insights of what kind of values we have and what are their frequency. So we can have the overall idea from here, and we can move to the next column. So now we are done with the columns, and now we are going to look around the missing values. So for this thing, I'm using missing and go package. This is a good package. This will give an overall picture of about the missing values and the location where it is actually missed. So this is helpful to derive or to see is there anything following any pattern while missing the values or not. So if you take the complete data frame, this will take time. Wait. So yeah, here the recruitment contact we have saw in the first stage itself, but it does not have any value. Where the post until it has only few values like some around 10 to 20% of values, and yeah, that's it. So if you want to find the location where the value is actually missing or the value is actually there, we can use the matrix. We can use this matrix of method to see the overview of the data frame. Yes. So here, if you see in the minimum qualification requirements, only one row is missing, and if you see the requirement recruitment contact, everything is missing. So the complete column is empty. So if you see the post until data, only few things are missing, and there is no relation between any of the columns. All the other columns are having data. Only these three columns having null data. That too, this column is completely empty. So what we can do is we can actually delete this column, this recruitment contact. So that is completely different topic that I'll be covering in the different video, how to deal with the missing values and how to prepare the data. This is all about doing the data analysis. This is all about doing the exploratory data analysis of the data. Following this video, I'll be posting another video which has how to prepare the data to develop a machine learning model. So here the video ends, and I hope you learned something from this video. If you do so, please like this video and share this video to your friends. If you want me to do any other content related to data science, please comment those things in the below comment box. I'll be posting those videos. Thank you.